Welcome to the Explainer. Okay, picture the exam hall like the trading floor of a major stock exchange. It is intense, the clock is relentlessly ticking, and you are being forced to make split-second decisions about where to invest your most valuable asset, your time. Today, we're putting on the examiner's lens and looking deeply at the Cambridge AS and A-level computer science syllabus, specifically Code 9618. We are going to master the complex theory and methodology behind a topic that consistently acts as the ultimate gatekeeper to the absolute highest grades, relative addressing. Now, if you've been following the progression from your foundational IGCSE years, whether you studied syllabus 0417, 0478, 0983, 0984, or even 2210, you know the basics of memory. But A-level 9618 demands an entirely new level of precision. To show you what I mean, let's look at a classic past paper scenario, similar to the infamous 9713 papers. Let me introduce you to two typical candidates, Alex and Sam. Alex is our walking textbook. Alex overloads every answer with raw computer science facts but offers absolutely no analysis. Sam, on the other hand, is our speedster. Sam rushes, completely misses the command word requirements, and throws away easy marks. Throughout this explainer, we are going to look at their flawed answers side by side with the examiner's red pen marks and show you exactly how to avoid their traps. If you're a focused learner looking to truly grasp how a computer calculates memory addresses dynamically, and more importantly, how to communicate that under extreme pressure, you are in the perfect place.
So let's dive straight into the stakes. 15%. Why are we dedicating this entire session to addressing modes and relative addressing specifically? Well, because according to the breakdown of past exam data, this concept and its associated applications account for approximately 15% of the total marks in Cambridge Paper 2. Think about that for a second. 15%. That is not a rounding error. That is often the entire gap between two full grade boundaries. It's the difference between an A and a C. This isn't just a minor piece of trivia to memorize the night before. It's a foundational pillar of the paper. You simply cannot afford to leave these marks on the table. You need to invest your time where the marks are highest, and right now, this is the jackpot.
But here is the paradox, right? Even knowing how heavily it's weighted, students like Alex and Sam consistently drop marks here year after year. Which brings us to the core issue. Why do students struggle so much to apply these concepts to unfamiliar contexts? You see, memorizing the definition of relative addressing, knowing that it uses the instructions operand as an offset to the program counter so the code can be loaded anywhere in memory, that's the easy part. Alex does that flawlessly. The struggle happens in the exam hall when that familiar definition is wrapped in a completely novel, unfamiliar context, like a robotic arm control system or a real-time sensor array. The source material tells us that the disconnect isn't usually a lack of basic knowledge. It's a lack of transferable conceptual understanding. They know the what, but under pressure, they completely lose the how and the why. To fix that, we need a strategy. Here is our roadmap for today. First, we'll hit the core principles and theory. Second, we'll break down the procedural framework. Third, we'll dive into algorithm evaluation. And finally, we'll look at the top examiner warnings so you don't fall into the same traps as Alex and Sam. Let's get to work. Let's start with Section 1, Core Principles and Theory. This is the foundation that absolutely everything else is built upon. Notice how the Cambridge syllabus actually assesses you. Examiners aren't just looking for one type of thinking. They target three distinct cognitive domains. First is knowledge and understanding. This is Alex's comfort zone, knowing the definitions. Second is application. Can you take that definition and use it in a given scenario? And third is analysis. Can you break down a complex system and explain exactly how relative addressing optimizes it? True mastery means your conceptual understanding fluidly moves through all three. This is where we introduce the ultimate strategy for Cambridge computer science, the PEAL framework: point, evidence, explanation, link. Top students don't just dump facts. They structure their answers. They make a point, back it up with evidence from the scenario, provide an explanation of the technical mechanics, and link it back to the command word in the question. If you only practice the knowledge part, you'll hit a brick wall the moment the exam asks you to analyze or evaluate. And this brilliantly illustrates what it takes to get those top-tier marks. This quote is pulled directly from the principal examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. The theoretical architecture of relative addressing doesn't exist in a vacuum. It rests on causal relationships and integration with other syllabus areas. If you can explain how relative addressing relates to array manipulation or how it affects the fetch-execute cycle, you are signaling to the examiner that you understand the complete system.
Before we continue, subscribe to our YouTube channel Ace the Exams at @aceexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, that brings us to Section 2, the procedural framework. Now that we understand the theory and what examiners are actively hunting for, how do we systematically tackle the actual examination questions to guarantee those marks? Here is where the transformation happens. The crucial point is the method mark strategy. Process equals points, period. In Computer Science 9618, extracting data from binary representations and performing address calculations isn't just about getting the right final number. You are graded on your evidence-based reasoning. Examiners award marks for the process. Think about Sam, or Rusher. Sam leaps straight to the final answer in his head, makes one tiny binary arithmetic error, and scores 0. Brutal, right? But if Sam lays out his process clearly, showing the base address, showing the offset, and makes that exact same arithmetic error at the end, he still picks up the majority of the method marks. Those red pen marks suddenly start transforming into green check marks. Let me show you the exact computer science success blueprint to structure that process.
Whenever you face an algorithmic problem, I want you to follow this exact 5-step sequence. 1. Identify the key elements, like your current program counter and your offset. 2. Apply the relevant principles. 3. Execute with crystal clear working. 4. Verify that your calculated address actually makes logical sense. And 5. Present your conclusion with precise formatting. If we put 60 seconds on the clock right now and asked Alex and Sam to rewrite their answers using this blueprint, the difference in their mark potential would skyrocket from 20% to 100%. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's transition to Section 3, Algorithm Evaluation. We are moving into the critical analysis phase, which is exactly where the absolute highest marks in the entire paper are hiding.
All right, it is time for an interactive workshop. Top-scoring candidates demonstrate evaluative thinking by navigating distinct trade-offs using a deconstruct, solve, evaluate model. Let's do Challenge 1, the data scan. Look at the table on screen. Imagine a 60-second timer is counting down. I want you to extract the core trend. You have to evaluate the algorithm's quality by analyzing time complexity, how fast it runs, against space complexity, how much memory it eats up. Got it? Okay, moving to Challenge 2, find the flaw. Imagine Sam writes a paragraph saying an algorithm is perfectly efficient just because it has low space complexity, completely ignoring the boundary conditions. Can you spot the sentence losing marks? Yep, Sam failed to identify the edge cases and their effect on performance. Acknowledging the limitations of your solution and justifying your decisions with solid evidence is the hallmark of a top-tier candidate. Finally, Challenge 3, speed writing. If you had 30 seconds, could you write one perfect Peel paragraph explaining this trade-off? Point, evidence, explanation, link. It shows you aren't just coding blindly. You are engineering a robust solution.
Which leads us perfectly into our final and honestly perhaps most vital section. Section 4, Top Examiner Warnings. We've talked extensively about what to do, but the principal examiner reports also give us exclusive insider knowledge on what not to do. Examiners constantly highlight 3 massive traps, and this feeds right into our final answering system. The first rule for top marks is command word decoding, because the most classic mistake is using the wrong algorithmic logic for the context. If you apply absolute addressing logic to a relative context, your whole calculation falls apart. The second rule is applying that Peel framework we discussed, because students routinely forget to check boundary conditions. What actually happens if the offset pushes the address entirely out of bounds? And the third rule is utilizing a time management matrix. Don't rush like Sam and provide generic answers. You must link your logic to the specific context given in the exam, whether that's a database index or an embedded system. Let's look at this side by side. The principal examiner reports reveal another major red alert. Candidates consistently confuse key terminology. Our struggling candidate, much like Alex on a bad day, uses terms interchangeably or vaguely, basically just hoping the examiner will miraculously guess what they mean. The top candidate does the exact opposite. They define their terms explicitly before using them in their extended responses, and then they link those terms to cross-topic connections. Remember, precision in your language reflects precision in your thought. You have to show them you know exactly what you're talking about.
So, how do you remember all of this when the pressure is on? To help lock this in under the intense stress of the exam hall, the source material suggests a memory hack. Create a personal acronym for the crucial factors affecting relative addressing. Let's use the 3 big traps we just discussed: context, complexity, and edge cases. CCC. When you open paper 2, flip to a 15-mark question on addressing modes, and feel that panic rising, just write CCC at the top of the page. It instantly forces your brain to slow down, evaluate the specific context, manage the time and space complexity, and rigorously check those edge cases before you ever finalize your answer. As we reach 100% on our mark potential progress bar and wrap up this explainer, I want to leave you with a provocative question. Are you actually checking your edge cases, or are you just hoping for the best? True mastery of Computer Science 9618 doesn't come from blind hope. It comes from rigorous methodology, systematic processing, and a deep understanding of the causal relationships behind every single line of code. Take these strategies, apply the procedural framework, decode those command words, and start hunting down those marks. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.